Good afternoon, everybody. Thank you for joining us today for our second webinar series. Today we have Mohammed from Southwire presenting IEEE Duct bank calculations. So Mohammed, I will hand over the floor to you.
Sure. Good afternoon, everyone. Can everyone hear me?
Yep.
Okay, awesome. Good afternoon, everyone. Welcome to the Underground Duct Bank webinar. My name is Mohammed Saad Rouzzadeh. I'm a contractor solution specialist from Southwire, Canada. First and foremost, I would like to thank Noramco for the opportunity and everyone on this call for taking the time from your busy schedule to join me. As you know, in modern business, if there is a presentation, there is a PowerPoint with it. So here comes another one. I'd like to mention, realizing that some just finished their lunch, and with the KISS principle, I will be trying to stay away from too much details, especially formulas. So let me start by giving you some background information. Power distribution industry has seen grow over the past couple of decades as the need for electricity continues to grow. Over the past decade, underground power distribution has become increasingly popular. With the technological advance in this area, the process of running these cables has become more cost-effective and efficient. However, there has not been much of change in the techniques used for distribution, but rather to improve what the industry refers to as standards. There are two major methods of power distribution, the use of the overhead and underground lines. Each of these methods, like everything else in life, have their own advantages and disadvantages. So the overhead option allows for easy repair in case of faults, and one can easily add and modify the lines, while the underground option is favored when trying to run power lines around above ground barriers such as buildings or highways and so on and so forth. As you all know, overhead power lines cost less to build and service when compared to its underground alternative. However, underground power lines are more appealingly pleasing. They are reliable, they're safer, and they require less maintenance due to its lack of exposure to accidents on the road or harsh element in nature, as well as the high probability of failure during the weather emergencies or natural diseases. Cables for underground service may be classified either according to the type of the insulation material used in their manufacturing or the voltage of their manufacturer. The latter method classification is generally preferred, and based on that, cable can be divided into a few groups. So one is going to be, for example, low tension cables. So basically cables up to 1 kV, which is going to be the subject of this webinar conversation today. So then it's going to be high tension, up to 11 kV, and then super tension up to something from 22 to 33 kV, and so on and so forth. Now, following the selection of the cable for an underground power distribution project, one must decide between the two major methods of laying the underground cables, namely either directly burying it or using a duct bank raceway. So for direct buried raceway, basically, what happens is a trench of specified depth is dug, then a bed of fine sand is used to prevent moisture from reaching the cables. After that, the power line are run directly over this bed of sand, and you know the rest. As per duct bank raceway, the second method involves the use of casing rather than the lines being directly in contact with earth. Here, a trench is mined and then filled with concrete enclosing, basically space conduits like PVC and DB2 that will contain the power cable. The concrete helps protect the conduits or cable from any moisture in the soil, which in turn prolongs the life of the material. The conduits, however, apart from helping properly space and separate the cables, also facilitate the cable pulling process. as well as allow modification and easier fault localization than its direct buried counterparts. Of the two methods, the direct buried raceway requires less capital for initial construction and has superior heat dissipation. However, maintenance and modifications of the line prove to be very costly. They require diggings. Also, with this method, the process of locating faults becomes challenging. I recall a few years back, we were received about 2 or 3 requests for IEEE 835 calculation each year. This is for building wires in Ontario, which I'm aware of. Year to date, we have completed over 30 calculations only for Ontario. I do have a couple of more actually in my basic inbox now. And I trust my counterpart in Western Canada, Jordan Ellis, have done way more than that. So I think the awareness alongside with the City of Calgary's inspection request could be the main reason for this change. These ESA people, I guess they talk to each other. So basically since what was that, about 2014, actually, there was a presentation and City of Calgary made it mandatory in Calgary that, anytime a deviation, if there is a deviation from the, CE book and all these tables and diagrams, and IEEE 835 calculation has to be basically provided. And I think it's ESA people, they talk with each other because since then, actually, I see a lot in Ontario as well. Another reason for the lack of the demand in prior years could be the lack of awareness in contractors' word about Southwire and, their ability to help. Let's continue with CE code and conductor selection, though. So as you're aware, using accurate cable ampacity is critical to the electrical power system design because an optimally sized cable results in minimum cost and high reliability. There are several methods used to calculate cable ampacities. There's a Noramco method, there's cable ampacity tables, and commercially available programs. So speaking of the tables and diagrams, our focus today is going to be primarily on ampacity, which can be defined as the maximum current the power line can operate and still sustain its desired electrical properties, which is sometimes referred to as a cable's current carrying capacity. CEC 2015 book, part 1, I can say page 1 to 3, I guess, talks about installation of the conduit above ground. Can be found in ampacities of conductors in cable tray section, and contractors are very familiar with that. There are tables named in section 4, like D11A, D11B, and related diagrams can be found. This can be found at Appendix D as well. However, it seems some contractors are not as familiar with Appendix D. The tables that noted over there, I'm trying to bring up some pictures, so if you can bear with me. So these are the tables. As you see, the appeal and convenience of this method is that it allows engineers and technical designers to easily look up the corresponding cable sizes based on the listed ampacities rather than using the actual Noramco method to calculate the respective values. Basically, the ampacity of power cable is limited or governed by the maximum operating temperature of the insulation as its best performance. As an example, the cable constructed with a cross-linked polyethylene or XLPE or RW90 or RW90, whatever it's called in the industry. So XLPE, basically dielectric, are typically restricted to be maximum temperature of 90 degrees C. However, the weak point would be the other elements in the system, like the termination, which usually rated for 75 C. It is important to understand that these tables were created with certain base assumptions. These assumptions, for example, include the ambient temperature of the earth being 20 degrees C, but many locations in North America, as you know, experience the maximum underground soil temperature of 25 C or even 30 degrees C, depending, where what is the location. So definitely this is going to reduce the ampacity by 5% to 8% below the tabulated values. After all these approximations are made, their variation from the actual value add up, which may result in significant discrepancies and wrongly basically sized cable. Let's move on to the IEEE 835 cable sizing method. There is a variety of wire and cable materials, and this, in addition to the ambient condition of the raceways and multiple other factors, complicates the cable sizing process. It is unfortunate in the CE book there are not much actually to help with this complicated engineering calculation. These above mentioned simplifications reduces the cost of the design, but can result in errors and or a life cycle cost that is higher than necessary. Research has shown that there are many factors affecting underground cable ampacity calculations. Just gonna name a few. So basically it's gonna be conductor's material and caliber, ambient temperature or duct size, soil's thermal resistivity and size of the backfill, proximity of the cables and depth of the installation, which is very important. I know that in industry there is a kind of the misunderstanding that the deeper we bury the cable, the better it is. I think they think it's going to be mechanically protected, but it's otherwise. Basically, the deeper you go, you're going to have less heat transfer, and it's going to basically overheat the cable. Each of these variables can affect the temperature rating and ampacity of the cable and requires further investigations. In next slide, we're going to look at one, just an example. So let's look at the effect of the RHO, so the backfill, or regardless of whether a cable is laid using the direct buried or duct bank method, the RHO, which is defined as the soil or backfill material, is a very important component that is not to be overlooked. RHO is an indicator of what heat transfer capability of a uniform filler through conduction, and it is expressed in that's centimeters per watt. In North America, though, the RHO values for soil in different parts of the country can be as low as 60 in wet soils, up to 120 in very rocky or dry and sandy areas. No need to mention that the filler chosen also has its own RHO values, which can go from 50 C all the way to 90. So this relates to what I was saying earlier, that it is important to understand that tables and diagrams were created with certain base assumptions. Earth characters as well as specifications of the material used when laying underground distribution lines vary. As I said before, selection tables are convenient, but the built-in assumptions are almost always overlooked. Thus, after all these approximations are made, there are variations from the actual value adds up. So again, that may result in significant discrepancies and wrongly sized cables. As per IEEE calculation, we will be happy to help with common application at no cost. If original design meets the CEC basic restrictions, then we will let the client know and share our thoughts in assisting further with their project if inquired. If the design doesn't meet the requirements, then we will ask for more information, enabling us basically to perform an IEEE 835 calculation. So whenever a calculation is needed, we would ask for some information to qualify the application and its requirements. To make the process easy and efficient, we have made a kind of a 3-page questionnaire, which can be used to fill in the blank. At a glance, it might look scary, but believe me, it's very straightforward and not as bad as it looks. For example, the first page is only asking for the contacts at contractor, distributor, and if that's the case, maybe the design engineer. The reason being for that, if we need further information or if we need a clarification, we know how to contact. On the second page, only one of the sections, I don't know if you can see it or not, it says C, D, or E must be answered, which is basically is about dimension and burial depth of the raceway and conduits. And lastly, on the third page, questions are about, the size and type of the cable which has been selected, number of runs, configuration or the layout of the conduits, the total ampacity of the system. This is something that the contractor already knows. So, and I don't think overall fitting this information, it would take, anything more than 3 to 5 minutes, provided that the contractor has all this info. Now, what happens next is as soon as we receive that one, if we don't see a vital information missing, then we will call back to clarify. Otherwise, if basically we see a vital information missing, we will call back to clarify. Otherwise, we do the calculation within 3 to 5 business days, I can say. Since this would be based on our material or, basically based on the particular manufacturer's material, for the sake of this conversation, it's going to be Southwire material, which their properties are very well known to us. We will put not for construction watermark on the report. And upon receiving a confirmation that materials being installed meets the material indicated in the report, or basically it's going to be Southwire product or whoever, we will remove the watermark and send back the final report, which can be shared with ESA or engineering team or the owner. If there are any flags on the calculation result, so meaning selected cable might not match the job requirements, and what we do, we will circle back and work with the contractor or the engineer on finding the best possible solution for the application. We have to remember that as much as we are eager to help, there are things we are not willing to do for many reasons. As an example, not going to act as a design engineer or electrical contractor and so on. And also we keep the liability in mind. So I'd like to expand on another support which we offer to electrical contractors for many years. The reason is the fact that we know many contractors in the field are not aware of Southwire's many solutions and resources which is available to them. Based on our finding, I can say over 80% of the premature cable failure happens during installation, and most of them are invisible. Thus, we are offering our help to plan and build an entire wire pool in advance, complete with pooling tension and sidewall pressures. This would go a long way from basically selecting appropriate equipment, deciding on the best pool and feed locations, the number of the people, and estimated time required to complete the job, and more. This can be subject to another webinar or conversation, but in the meantime, please don't hesitate to ask for more information if you are interested. So in conclusion, let me add another point. Please don't hesitate to call Noramco or Southwire if you can be of any assistance in light of our product or solution offerings. We welcome any question that may be related to your current projects or those of general interest. Again, I want to thank you everyone for your attention.